Okay, so thank you everyone, and if everyone could just grab a seat now, because it's the event is about to start. Pascal was a bit late because there was a traffic jam from Cologne to here. Yeah, but I think now we are all ready. And so a warm welcome from my side. My name is Frederick, and I want to welcome you to our second Flutter School meetup, which is about Flutter, material design, everything you actually need in order to build your digital product. So I just start with a short intro talk so you know what we are doing today, and also, yeah, where some amenities are and stuff like that. So first of all, yeah, drinks. If you turn around, you can find the drinks right behind you. We have basically everything that is kind of soft drinkish. Unfortunately, no beer today. And also, if you need to go to the restrooms are right over there. There's the men's room, and yeah, the next door is for the women. Yeah, and before we start, I just wanted to let you know that we also planned a Flutter hackathon, like similar to a study jam, and you can register for that because this is like actually next month on the 12th, sorry, but this time in Cologne. So keep that in mind. Go ahead and check it out. If you're a beginner or new to Flutter, you should definitely check this out. And even for the upcoming Flutter Create contest, where you can win prizes up to 10K, like in iMac or Google Home Max, yeah, you should definitely join us, and then you will have the skills afterwards to create your own app. Yeah, so first of all, also before we start, a big thank you to our sponsors, 2 Dimensions for the pizza, and Spaces Sonja for the amenities here, for the room and the location. It's not always that easy to find a room for so many people here. So thank you very much. Also today our 2 speakers are Pascal Welch and Johannes Milke from, he's also sitting back there. Johannes Milke will talk about Flare. So also this is why we have 2 Dimensions as a sponsor, and he will show you how to build like nice animations, SVG animations in Flutter. And Pascal will talk about like CI and how to set up continuous integration for Flutter. If you want to give something back to us, we also have a Twitter account at Flutter School. You can also use the Flutter School hashtags, the Flutter hashtag on always. Maybe tag Flutter, which will reach Nile, and she's the community manager of the whole Flutter social team. Yeah, and if you want to follow Georg and me, we are just like basically the founders of this meetup. Yeah, you're welcome. And that's basically already it. I hope you have a good evening, and also later when we have the discussion and the socializing, would be cool if you stay for some more time, so that we can have the interesting discussions afterwards and the networking part. And for now, I would say, let's start with Pascal's talk about the continuous integration in Flutter. So, yeah, we're just waiting for Pascal to come here. So thank you, and that's it. Ja, das geht sehr gut.
Yeah. Okay. My presentation today requires internet. That's why I had to check it there. Okay. Let's do this. I want to talk today about Flutter continuous integration. And yeah, first of all, who am I? I'm Pascal Welch. I work in Cologne for Grand Centrics. We do IoT and I do the app parts. And I love doing it in Flutter because clients always want fancy animations, and I can do this with Flutter, not with Android. I'm a GDE for Flutter, and I should update this. I now have an official Flutter badge, and I'm not part of the web technologies department anymore. I'm very happy about that. We will talk today about continuous integration and continuous delivery. I want to separate those two parts because this is the one I want to focus on. And continuous delivery is basically the one which CodeMagic does. And continuous integration is the thing you should always run if you commit code to any project. It tells you if the project is still able to build, if the app still works, or if all tests are running, and if the code you submitted follows the coding standards of the project, like static analysis. Those are the three things I will talk today about: Flutter build, Flutter test, and Flutter analyze. And because I really want to show you how this works, I will create a new project and we will set up continuous integration with GitLab. And yeah, I will immediately jump into code. And this is basically what we will do. We will create a new project and add a GitLab CI YAML file to the project. What we will do there, this will build every time we submit code. It starts a Docker image. Here it starts the 0CI Flutter Docker image with Flutter 1.0.0. And before we run our script, we run Flutter Docker just to make sure to log everything which is part of the environment. So we log the installed version of Java, we install the version of Dart, which is installed, all that. So in case it fails, we have more information why it fails. And then we build the app, here AOT, we build or we run all the tests, and then we analyze our code to the static analysis. And I will immediately try it here. So please tell me if you can read something. Okay. Let's create a new project.
Could you make it a little bit bigger?
Sure.
Yeah, that's perfect. You can even read this on the live stream.
Wow. So we have 2019. 2019. And here I will create a new project with Flutter. I have Flutter installed on my laptop here, and I Flutter create dot, which installs Flutter in the current directory. And all done. Great. The next thing we do, we want to run it, of course. We can type Flutter run, and we have a new project. And we should see it here live in the simulator, in the IO simulator. It should start in the next second. Now we run Xcode build, and we compile everything. I will, in a minute, explain you exactly what's happening there. And yeah, Xcode build is done, and now the files are synced to the project, and we have our wonderful example project in Flutter. So let's stop this, and let's open it up and drop our YAML file inside. I created it here, just drop it here, and I will show you the content of the file in Visual Studio Code. So this is exactly what I showed you. This is the Docker image we are running, and Flutter Docker build, test, and analyze. I will push this immediately to GitLab, which I will use today for demonstration how CI works. So let's create a new project here, Flutter School 2019. And of course I make it public so everyone can have a look. And I'm not good at running git commands in the command line. So, oh, I forgot to initialize git init add the remote, add all the content, and commit everything exactly as displayed here, and push everything to master. Because we already added the GitLab YAML file, it will immediately start a build on CI. So now it takes a second because I'm using my phone to, yeah, it works. You can now see the project here. Yeah, the code or the project is now pushed, and we will see in CI that something started. So the build is running, and we can jump inside and see what's happening there. This takes a while because the Docker image is pulled and built, and then it will execute. In the meantime, I will tell you more how all of this works. Back to the presentation. Okay, the promise of creating Flutter applications or creating cross-platform applications is that you have a single code base, and this would be amazing. The reality is, actually, you have a code base in Flutter, and you have N platform wrappers. This means you have a wrapper for Android, for iOS, for Windows, for Mac, for Linux, for Fuchsia, whatever, whatever Flutter supports. So you end up with more than one project, more than two projects you would normally do if you build everything natively. You end up with at least 3 projects. It looks like this. We have the Flutter code base. This is all written in Dart. And we have the embedder projects, which embed the Flutter project and basically display everything Flutter renders. In a perfect code base, the Flutter code will grow and grow and grow, and the other ones are still tiny wrappers around that Flutter code base. In this case, we have 0 problems, everything works. But in reality, the code bases of the embedders also grow. There are some adjustments here and there. If you created a Flutter app, or if you published a Flutter app, you will also have to manipulate the embedder apps to add app icons, add permissions, and also all the plugins you are using for your projects are adding code and resources as well to the embedders. I will show you how this actually looks for Android. This is what the content of an Android app looks like. I opened it in Android Studio, and you see it's a pure Android app. You have the components, the embedder component, which is the Android manifest, one of the core files which is required for every Android application. The next thing we have is the classes.dex. This contains the platform code for running Android apps. So there's one activity with Java code, which then starts Flutter. There is some core code of Flutter itself. For example, the Flutter view.java file. And there is some plugin source code. So the plugin registration and also the content of the plugins written in Java or Kotlin. The real core of Flutter, the C++ part or the runtime, here especially the Skia code, which actually renders everything to the screen, is part of this lib directory. This is native code. This is especially compiled for an ARM architecture. Your code, the code you are writing in your Dart or Flutter app, is split into those files. There's a VM snapshot and an isolate snapshot. I don't want to go into details, but VM is everything which is part of the VMs, things like the int class or the num class, string class, things like that. The isolate snapshot is the thing you're running in your app. This is code which only runs in the main isolate, so your app widget will be part of that. It is split into instructions and data. Instructions is the thing which are executed on demand. If the code block is executed. Data is the thing, if you put const somewhere before a constructor, const will be, all const objects will be created at compile time, and they will be added to the snapshot data. You can see here, data is actually bigger than instructions. So it's really worth it to add const everywhere because it's not executed, it's already pre-compiled. And last but not least, the assets are also bundled inside the APK. These are the assets which are defined in the pubspec YAML file. We can add here some responsibility. So the responsibility of the Flutter SDK is compiling the Flutter core or delivering the Flutter core, compiling the Dart code, and combining all the assets. And then hand it over to the embedder SDK, embed this into your application, and also hand over the plugins. And the plugins and the platform code of the embedder will be compiled with a tool chain of that specific platform. The thing is, CI for all the stuff of Flutter is pretty easy. The tooling is great. But if you want to have CI for every individual embedder, it's harder. You have to use the tools which every embedder offers. So it's no surprise that the iOS toolchain is not as good as the Android toolchain. Therefore, you have a harder time building your Flutter app for iOS than for Android. Oh. Yeah, so please never blame Flutter for the lacking iOS toolchain. They can't do anything about it. They can make it as good as it's possible with the iOS toolchain, but yeah, you can't build iOS apps on Windows, so you can't build Flutter apps on Windows. The thing of mobile development and why CI always struggles in mobile development is that Android, for example, offers an emulator. So if you want to run your UI tests, you have to start an emulator. Also for instrumentation tests, non-UI tests, you also have to start the emulator. You cannot always use the JVM to execute your tests. The same thing for iOS. UI tests only work on iOS, and iOS apps can't be built on Linux. I'm sorry. One of the solutions which were used a couple last years is Jenkins. And one of the reasons we at Grandcentrix use Jenkins is because it's so easy to create runners for OS X. There are not many other CI tooling libraries out there to offer this. Flutter CI, as I already told you, is easy. Dart compiles on every operating system. The same happens with tests. You can execute all Dart tests on every OS. So this is great. You can use it on your Windows machine. You can run it on your Linux server, whatever. And as I already told you, the embedder project is the hard part. You have to use what the embedder offers. Now, what's possible with the pure Flutter toolchain? We can build the app, at least parts of it. We can compile we can pre-compile the Dart code. So there will be these files, the data file and the instruction file. We can pre-compile those snapshots. We can run all unit tests. We can run UI tests. And this is amazing coming from Android background. I can run UI tests without having an emulator. And I really like this. Static analysis tool, I think this is the same across all mobile platforms. You can run static analysis on any code. We have Lint, Dagger, Danger, and they work cross-platform, and there are great plugins out there. So you might ask, which is the best CI for Flutter? I already told you Jenkins could be used, and we are currently using GitLab CI. Actually, all of those are possible. The only thing, if you want to have tooling for Flutter, you can use all of those because everything, all of those CI systems support Docker. You can start your Docker image there, and you have a full Flutter toolchain, do everything you want. But if you want to build iOS applications, if you want to create applications for Windows with Flutter, you have to use CI, which offers those runners, those slaves on that operating system. So those commands are now executed on GitLab, and we will jump straight into it. What was happening? So I will increase the font size here. The first thing is flutter doctor verbose, and it prints all the information. So this one was executed on Linux, and it had the Android toolchain installed, which is actually not required, but this Docker image had the Android toolchain. Yeah, we can see some more things. Then the next thing is Flutter build AOT. AOT is the ahead of time compiled Dart code. And yeah, it takes a while and it builds stuff and it prints a lot of things. And in the end, it built the AOT snapshot in release mode for a specific architecture, which is Android ARM here. Then I ran all the tests. Thankfully, the sample application has some tests, even some UI tests. So you can see you can run UI tests in any Docker container. And the last thing is Flutter analyze. There are no issues in the sample. Good for us. And the job succeeded, and we can now see a small check mark anywhere in our CI. But we can improve even further. Let's go back to the presentation. Ah, there it is. So what is the Docker image actually doing? Actually, it's cloning the Git repository. You can also download a zip file of the Flutter, but actually it's just a snapshot of Git. It even includes some of the Git files, and it exports to the path the bin folder of the extracted Flutter Git repository. And there are all the executables like Flutter itself, Dart format, and other tooling. I was pretty amazed when I saw the system requirements, especially if you're using Docker, you want your images to be as small as possible. And there are not many requirements for Dart. Actually, all those tools are more or less pre-installed. And the only thing which is important for testing is this libglu.so. You can install it as well. There are enough Docker files out there. So the real amazing part is that you don't need to install Dart. Dart is shipped with the SDK. You don't need to install some Flutter engine, and you don't need to install Java, the Android SDK, or the Xcode toolchain. All of those are optional if you don't use this embedder. If you want to create a binary of a specific embedder, you have to have it, but they are not required. The biggest problem is when you're upgrading Flutter, and this happens a lot. At least for me, I usually upgrade Flutter because when I'm switching projects, I update here and then I update there, like twice a week. And I always forget to upgrade Flutter as well on my CI server. And this is a real problem. Also, if you're working in a larger team, if you upgrade Flutter, you have to go to your coworkers and tell them, please update your Flutter, because Flutter is mostly installed on your system. Especially if you're switching projects, this can become a real problem because all projects suddenly use the same version of Flutter. And I'm not a fan of this, so I created a thing. Yeah. First of all, never you should make your CI builds reproducible, especially when we go to delivery. And this is because if a client gets an APK from you and somehow loses it and finds a bug in that specific version, you want to be able to build that specific version again, maybe with a hotfix. So you want to have the same environment again, the same Flutter version again, and not use a dependency on your local host machine. That's not how we are professionally developing software. So make Flutter part of your project. And how can you do it? I created a thing called Flutter wrapper. And if you're familiar with the Android toolchain, it uses Gradle, and there's a Gradle wrapper. And what it does is it downloads Gradle at a right version before you execute it. And that's exactly what Flutter wrapper does. It downloads the Flutter to your project at a specific version and then executes Flutter. So you have for every Flutter project a specific Flutter version, and you can upgrade every project individually. So instead of Flutter build, use Flutter W build. And I will show you how to install it. You search at Google for Flutter wrapper, and you will come to this project. You copy the install script and go to your project. Simply execute it. It takes a while. It creates internally a submodule of Git, so you have to have Git. Sorry, no SVN. And it downloads the complete repository. There's no swallow download option because you are now able to switch between versions very easily. This takes a while because everything goes through LTE. In the meantime, I want to show you what Flutter build actually offers. As I already mentioned, AOT, which compiles the Dart code to ahead of time compiled Dart code, which can then be executed on ARM. And you also are able to build specific releases for Android, which is APK, and iOS for iOS. Also, there is a bundle command, and it combines all the assets and prepares them to be moved to a specific embedder. So now that we have a specific version of Flutter, we also don't want to be locked into a specific vendor, here a specific CI. For private projects, I most of the time use GitLab CI. At work, I use Jenkins. And for open source, I often use Travis CI, which now got sold to a bigger company, and you shouldn't use it anymore. So I will most likely switch to some other CI vendor. All of those let you add a YAML file to your project, and then you are able to build it. But if you add multiple steps to build your project, like Flutter build, Flutter test, this can grow pretty much. So for example, for real projects, I have like 20 commands I want to run whenever I create a release. And that's why I create a bash script as part of my repository. And even when I'm switching the CI environment, I only have to execute that specific bash script. I even can run it locally. And it helps me a lot because I'm not vendor logged in. It looks like this. I add bin bash, if I have bash on that Docker container, and then I build, for example, the Android APK. I create shell script for every embedder and one for Flutter. So I have one build Flutter, which only builds my Flutter environment. I have one build Android, I have one build iOS, I have one build Windows. And so I'm able to only call that specific shell script on a specific executor on my CI. Let's do this. So first of all, you see here, this is the .flutter directory. This was added by Flutter wrapper, and I'm now able to execute it. Oh, it's still downloading. Oh, shit. But it doesn't matter because I should be able to submit it and push it to CI, and it's building there just fine. Because I'm not good at Git, I use fork. And if you have a Mac and you use source tree, for example, this is the better alternative. So use fork. It added a few files. So here's the submodule reference. It added the module, where it's come from. So you can even exchange it with your local fork of Flutter. And a small executable shell script, which handles the downloading part. But before I can submit this, I have to change my GitLab CI file to ./flutter_w. And because this script is downloading Flutter on demand at a specific version, I don't have to use Flutter anymore. That's why I created my own Docker image, which is this one here. Okay. Commit those, and it should now be able to build. Let's see if it worked. So it's running a new Docker container. Yeah, this time it's my Docker container, nothing is installed, but the dependencies of Flutter. Flutter will be downloaded on demand. And in the meantime, I'll show you more. This here is an example how to execute it on Jenkins, just so you can see that it works on multiple machines. I have a shell script, CIPR, for example, and it builds my project on Jenkins. And I can have multiple of those configuration files for each CI environment. If you don't use Docker, or if you're not familiar with Docker, I wasn't until like half a year ago, please use it. It's amazing, and I would never use again Jenkins with some slaves where some dependencies are installed. Everything is bundled within Docker. You can just start it. It's cached great, and yeah, it runs great on all CI environments. It even allows, especially if you're using GitLab, it even allows you to use your local machine to be a runner. And this comes in handy because GitLab, out of the box, only offers Linux CI runners. So when I want to build a project also on iOS, or if I want to build a release for iOS, I could use my local machine. That's fine. But actually, I should use a CI environment. And because I'm currently not paying for GitLab, they offer OS X runners, but I can make my local machine OS X runner. And I will show you how, because I was amazed when I tried it. So you go, by the way, it's building and it's downloading Flutter. In the meantime, I will go to the settings of CI. And there is the runners part. And I can create here, set up specific runner manually. I installed the GitLab runner with brew. And all I have to do is copy those over and then run GitLab runner. And I think it's GitLab runner register. Yeah. And now I have to enter the GitLab domain. I use gitlab.com, but you can host your own. And I also have to add this token here. And a description, flutter_school OS X. And now I have to add tags. You can define each step to be run on a specific tag. And for here, I will call it OS X. And I use shell. Great. And if we switch back to GitLab, it should pop up here. Yeah, this is my new runner, and now I'm able to run on the CI on my local machine. It sounds weird, but it's very helpful. All I have to do is change my GitLab file to this. So what has changed? Actually, this one here hasn't changed. I will build a build flutter sh, and I added tags. So Docker is the default tag. It uses an environment where Docker is available, and this actually runs on the GitLab service of GitLab itself. For Android, for example, I also use Docker, but I execute a different build command. And for iOS, I use macOS. Actually, I changed it. It's now called OS X. And I execute the build iOS file. Because I haven't added them here, I should add them to the CI folder. I simply change it, but you should definitely create them. And I will just call flutter build iOS. And because we want to have it fast, I only will create the iOS runner job. And we commit that as well, and it will run on my local machine, but it will report to the GitLab environment. In the meantime, we can check how our build with Flutter wrapper is doing. It's this one. It just finished. So you will see that the duration, it took a bit longer. Usually running Flutter build, test, and analyze takes around 3 minutes. This one takes about 5 minutes 30 because it downloaded Flutter. I'm willing to accept more time on CI because I'm currently changing my Flutter version like every week. If you're not changing your Flutter version regularly, you can use a Docker container or create your own Docker container with a specific version of Flutter. It helps the build times. So we can now see this is the other build, and actually it's waiting for an executor to be available with the tag OS X. Let's see what happens if I start this one. Still pending. Most likely because I'm currently connected with LTE and the connection is not that good. But usually it would just build the project on my local machine. There it starts. Great. Yeah. I will not do this with my mobile data enabled because downloading Flutter is like 1 or 2 gigabytes. I'm not willing to do that now. That's why I stopped the GitLab runner. And it should be interrupted. Yeah, system failure or something. But I'm able to build it on my local machine. So if you don't have an environment with OS X slaves on your GitLab, use your local machine. We can even improve our build Flutter. So I showed you 3 commands, but we can improve them even further. For example, we can run Flutter test with -- coverage. And this outputs the code coverage or it generates the code coverage while running the test. The problem here is it only generates the file which contains the code coverage. It doesn't print the code coverage. To do so, you have to install lcov and output it with this tool. I will have it on another slide. Yeah, there it is. So there is this dependency called lcov, and it offers this gen HTML binary, and you can create an HTML directory or HTML files of that coverage. And in GitLab, it also outputs the coverage % of that project in the command line. So you can parse it with GitLab and show like 80% code coverage, which is actually the case for the Hello World example. Another cool thing about embedding Flutter in your project is that you can also use other tools of which Flutter offers. For example, Dart format. You can also install Dart format at a specific version in your environment, but actually the rules of Dart format often changes. There are like 2 changes every month, and there will be slight differences in how the code will be formatted. So I will also pin Dart format. I will not use Dart format installed from somewhere else. I will use Dart format from that specific Flutter version I'm currently using. Additionally, you can use the Flutter format command, but it doesn't offer all the settings. For example, setExif change is not available with Flutter format, as well as the line length is also not available there. Yeah, that's what I just showed you. I can make my MacBook a GitLab runner. Building Android is actually super easy because there are Android Docker containers. Building iOS, that's not easy. If you want to create releases, I don't want to give you a big overview how you create releases for Android, how you create releases for iOS. The reason for this is there are great tutorials out there for years how to create good releases for Android. There are plenty of tutorials. Just use the Gradle command to create a release. For iOS, use Fastlane. You can also use it for Android. It works just great. For example, not only you can create releases, but you can also automatically upload your releases to Google Play, for example. There's this Gradle plugin called Gradle Play Publisher. It's even maintained by some Googlers. And yeah, there's this command publish APK, and it will publish the APK with some configurations to the specific Google Play account. Yeah. For iOS, use Xcode build. You can use the commands or use Fastlane to wrap it in a nicer API. You might have heard about Code Magic if you're into Flutter. It was announced at Flutter Live, and I tried it. It just works. It runs tests. It builds my app for Android and iOS. Cool. Especially cool if you don't have access to a Mac and you want to offer your users an iOS version. But I tried it and it worked, but I haven't added code signing. And the reason for that is they want your plain password for your iOS or your Apple developer portal. And I'm not willing to give anyone any of my passwords. And additionally, we can just look into it, how it looks like in the browser. So you have a glance. How's it called? Code Magic Home. Code Magic IO. I think here I built an example app. Unauthorized. Okay. What have I used? GitHub. Nope. I used GitLab because I used a private project there. There we go. Yeah, for example, I created here Flutter Mobile Cologne, and it was a similar sample project. I added a few tests, and we can look into it. Yeah, actually, it was preparing a machine. It was fetching my sources. It installed a dependency. We can even see what exactly was installed here. And then it was running my tests. Fine. There's no code coverage. Not so good. It was building my Android app. cool, I can do this as well. It was building my iOS app. This is actually a cool part. And it was publishing the artifacts. So it is hosting the artifacts on their own server and send you the links, the direct download links via email. But you cannot change anything. You cannot add code coverage. You cannot add other steps like checking the code formatting, check if it was submitted correctly. So you're very limited to just build. And that's why I want to split my presentation here. CI and continuous integration and continuous delivery are two parts. I personally would do both on the same system. So I would use GitLab for both. But if you don't have access to iOS machines, you can use CodeMagic to build your iOS app. And if you trust them, your Apple password. Yeah, what can they do? Thank you very much. Are there any questions? That's fine.
No questions. Okay.
Yeah, too much information.
Yeah, Pascal, thank you so much. Let me just reconnect the theme meeting. So I can also readjust the thing right now.
So yeah, thank you so much, everyone. Thank you, Pascal, for being here. That was the first talk. Right now, we have planned the pizza break. The pizza is on its way. It will be here in 1 or 2 minutes. And yeah, so please feel free to just grab some drinks or go to the restrooms real quick. And yeah, if you haven't, sign up for a study jam next month in Cologne. Yeah.
Check out the new flutter.school website.
The new flutter.school website has an amazing landing page. Yeah. Again, thank you very much to 2 Dimensions and Spaces. They are sponsoring the pizza, which is coming in, as I said, 1 or 2 minutes. And afterwards, we will have the presentation by Johannes about Flare. So yeah, feel free. And for the people on the live stream, we will be back in 10 minutes or so.
War das eigentlich die gleiche Auftrag wie letzte Woche?
Das weiß ich gar nicht. Der Weiterleiter weiß gar nicht dabei.
Sonst wäre der alles. Sollen wir das irgendwie? Kannst du ja so nebenbei immer mal ja.
Ui, was heißt, wenn ich mal Linksmodus.
Soll ich hier anschreiben wieder? Nee, das ist.
Ja, ist alles gut. Das ist doch alles an, oder nicht? Ja, ist alles gut. Ja, Mensch. Okay, thank you so much. That was very interesting discussions. And now we're going to have our second talk by Johannes, who's going to talk about Flare. Yeah, so I think let's just start. Yeah. Okay, so HDMI-Kabel.
Ja.
So. Also, ich weiß ja auch noch gedacht, aber sehr gut.
All right, my name is Johannes Milke, and I'm going to talk today about how to do animations in Flare. And first of all, I want to introduce myself. So my name is Johannes Milke, and currently I work at Livery, which is a small startup company in Berlin, where we develop mobile applications with Flutter. And I started with Flutter in 2017, when it was during its alpha version. And to the same time when I started with Flutter, I also started with Android in my university, where we had a small project with 6 people. And I just realized that I can do the same stuff which we did with these 6 people in Android. I can do the same stuff in Flutter and in the same time period and alone. And when I realized it, I decided to write my bachelor thesis about Flutter. So I developed 2 mobile applications, and after I wrote my bachelor thesis, I was even more determined about Flutter, and so I moved to Berlin to start there as a Flutter full-time software engineer. In my bachelor thesis, I also compared like Flutter, Ionic, Xamarin, and React Native, so that's also what I did. Today I want to talk about Flare. Flare is a tool where you can create complex animations, and we will integrate them into Flutter. And if you go to the Flare webpage, you will see the sentence here. Flare offers powerful real-time vector design and animation. And I want to emphasize here the vector. What does it mean? Vector graphics, it means like everything which we create with Flare can be scaled to different sizes and it wouldn't lose any quality. The opposite would be like raster graphics, so it's like a JPG or a PNG image. If you scale it to different size, it would lose its quality. So this is really powerful. You can create one time your Flare things and then put it to different screen sizes. When I first started with Flare, I always saw this here, which is pretty amazing. The teddy is following how you write. And I was always like, oh my God, this must be really complicated to achieve this with Flare and with Flutter. And I want to give you today a brief sense how you can achieve this with Flare and how to integrate it into Flutter. All right. Now I want to do a quick live demo. So I have here some sheets so that I don't get lost. So let's see. I hope everything works fine. See everything? All right. All right, this is like the Flare web tool. You can use it to create your design and your animations. And later we will export a binary file, which we then put into our Flutter application. And from your Flutter application, you can then access the things which you have created here. So I will quickly show you how to do it, and I will give you small example how to create something. So we have here this design tab, and then we can click here on create. And then we have here some like shapes, which you can use to do some elements, and also a pen to do like custom elements. And I want to do like an ellipse for this. So I will create it. And then you can click on it, and then you see on the right side all the properties which you can change. You can change the position of this element, the size, and so on. And I want to change the size to 430, for example, and 400. And yeah, we can then also convert it here to a path and edit vertices. And this is like you see the vertices of this shape. And then you can change it around and play around with it. So I want to create a face like you saw before, like a teddy, only in a really simplistic way. And I need to copy this color quickly. So we click done editing, and then we have here more properties which we can set for this. So I will set here the color which I copied, and the stroke. The stroke is like the thing which is going around our head. And you can move it also around. And everything what you create, you should name it. So I will create here, name it head. Now we created one shape. I also want to create some other shapes quickly. So you have here also this pen option to create your custom shapes. And let's see. Should work. So I want to create a neck, for example. So I will pretty easily connect these dots, and they will create these lines here. And then you can also move it around here if you made some mistakes. So it's pretty easy. Again, done editing, and I will also fill it with a color like this, and get rid of the stroke. So now we have this, and you have here also the option, you can change the drawing order. So you can change, okay, let's call it first of all neck, when things should be drawn, and I will change the drawing order. So let's see. So the head is in front of the neck currently. And you can also create other things which I want to do, like, for example, a mouse. So you quickly create a mouse, something like this. And if you press on one dot here, you have here some options like straight or mirrored, for example. And if you go with mirrored, it will mirror the lines next to this point. And I want to make it stretched. And I will also do it for this bottom dot here. And I will also do it mirrored. So it's again mirrored. And looks like this. All right, I think this should work. And I will give it a color of black, for example. And now you can here go to the translate mode and put it to the right position. By the way, I'm not a designer, so I'm a Flutter developer, and I will also show you later how to integrate it. So I will keep it short. And next thing I want to do quickly is to create a nose. So it's pretty easy. Oh, let's do it again. Okay, let's name it first of all mouse. Let's do it again. Nose. Done editing, and I will give it also the color of black. And here again to the translate mode and put it here. All right. I've created some other elements because I don't want to do it right now, everything, so it would be kind of boring, right? Let's do it. So I have created some hairs beforehand. And like you can see here, the hair or the head is in front, so you can change the drawing order. This is what I want to do here. I will put the head and the neck more to the bottom, All right, and then the hair is in front. And the next thing what we do is to move this around to the correct location. And what I did here is like I created this head or these hairs with this pen. So I just went there and did something like this and so on and connected these dots. All right. And I will also put the eyebrows here. All right. I will quickly go to this presentation again. So you saw here in this presentation that we have these moving eyes, and I also want to achieve this in Flutter and with Flare so that you can move your eyes around. And therefore, first of all, I will select the eyeball. Oh, I have to go there to the hierarchy. And here we have this eyeball, which is going around. And it's going out of this white background, and you can change it pretty easily by going here. You have a property which is called clipping, and you clip it. Here it says you should clip it to or pick a target, and then you clip it to the white background. And if you do it, you see like it's clipped, and you won't see that it is overlapping anymore. This is what we need later so that it looks realistic. And the same thing for the right eye. So we also want that it's not overlapping. So we add also this clipping, pick this target of this background, of this white background, and now it works also fine. All right, and I hope, yeah, right. And I will just move this eyes pretty here in to this position. And looks like this, which is pretty nice, I think. So the next thing I want to do is to create more things. So we have here some other options like a bone, a node, and a solo. And a node is something like really basic, like a widget in Flutter or an object in Java. So it's like the base object. And this can also be used like as a container where you can put multiple nodes inside or multiple things which you have created here. And I want to create a solo, which is also used, for example, okay, let's say nose. I want to create a solo for this hair. And so you can go here and create it by dragging it here into it, or you can use like Control Y, like it is said here. And if you do it, your hair will be wrapped around with the solo object. And what the solo object is doing, I will show you quickly. With the solo object, you can toggle between the visibility of these hairs, so you can hide them or show them. And this is later what we want to use in our Flutter application to make this hairs visible or hiding. Yeah, right. Then we have here also another thing like bones, and bones are really important to do like animations for some parts of the body. So I will create here one bone. So I just go to this point where I want this bone to have, like this. So we have one bone which is for the upper head and the other bone which is for the neck. And I will also name it here, head bone and neck bone. And now I have to put like everything which is here belongs to the upper head into this head bone. And I have to put the neck to the neck bone. And currently it's not supported that I can multi-select everything here inside. So I have to do it independently. But I think they will fix it in the future. All right, some more elements. So, and what does it bring? So let's see what happens. So we can, for example, rotate this head with this bone, and we can create our animation later with it. So I will bring it back to the start position. wait, not this one, to minus 90 degrees, right. All right, wait, one bone too much. Now we can also switch here from the design tab to the animate tab and create our own animations. And let's do it like this. I want to create an animation for this head bone, for this upper head. So I will go here and click on rotation because I want to change the rotation. And in the beginning, you have here a timeline where you say how this animation should proceed over time. So we have here, for example, 2 seconds, 4 seconds, 6 seconds, and so on. And we can then say how this object should be animated. And in this timeline, you can change between the different times with Control Shift right and left. So you just go there. And I want to go to the second 2 and then change it to the right side. Okay. I hope you can see good. It's not this big screen. All right, something like this. And I will create some more. So I will go to 4 seconds. And here I want to go to minus 170, the other direction. And I will also go to 6 seconds. And here I will go to minus 90 degrees to the initial position. And now everything should work fine, hopefully. And he's doing like this kind of animation, which we later can easily integrate into our Flutter application. And like you see, the speed of this head moving is always the same. But you can change it because it doesn't look like a human would move. So you can click on this dots here, for example, and change it to cubic. And then you can say how fast this animation should proceed from one stop here to the next stop. In this case, to 2 seconds. And now you see like it is going slowly and then faster, because we say here with this line, it should proceed slowly, then fast, and then slowly again. And I will do the same thing for 4 seconds, for example. So it is again slowly, then this animation will be faster and again slowly. You will see it from this point. Slow, fast, slow. And yeah, so you can play around with it and do your animation. All right. Let's see what we else can do. All right, we can change something about the neck, for example. See, where's the neck hiding? Ah, it's here, of course, neck bone. And then we can go to the neck and select the pass. And yeah, it's not working here good. Oh, we have to, of course, to go to the design tab. And then we click on connected bones. So we add our neck to this neck bone. Let's do it. And to this other bone. And if we are done, you see like both are connected to this neck. And yeah, then we can click here on edit vertices and edit weights and select the 2 top neck points. And what we do here is like we change it to a different value, which makes it deformable. You will see later what it does. So let's do it, done editing. So these both points will be deformable. So it means if we change here the rotation, you should see that the neck, this point is also moving. So that's what you can do. So it's deforming these points. All right. And another thing I want to say is how, because we still have these eyes here, and you want to get to know how you can move these eyes, for example. And what you are doing is, let's put it to the initial position. You create a node for your eyes. So we have here the right eye inner and left eye inner, and then you put them into a different node. So you go here with Control G for this node. So I will press Control G, and it's here in a different node, Control Face. And then you have to set here display target, which means, I hope it works. Let's see. Yeah, the eyes will move around this target. So later in our Flutter application, we would simply take this node, Control Face, and change its position. So it's not animated in Flare directly, but we will do this in the Flutter application. All right. And the last thing you do then is to go here to the right top and export this file. If you are done, select Flutter, which is predefined, and also binary.
What's the difference?
What's the difference between JSON and binary?
Yeah, are they? So why would you choose a different format?
Good question. I don't know. But most people take binary. I don't know if you could also take JSON, otherwise they wouldn't have it here for Flutter, I think. But just go with binary and you're safe, and export it. And then you download it and you have to place it into your Flutter project. All right. And now I want to continue with the presentation. Should everything talked about? All right. Now I want to talk how to integrate this thing which we created into Flutter. And first of all, you have to get the Flare plugin and install it, which you can get from pub.ling.org. And after you did it, you have access to the Flare actor widget and some other objects and so on. And this Flare actor widget is responsible for showing our binary file, which we have created before and which we have put in our assets folder. And another important thing what we do is to place a controller inside. And with this controller, we can access everything which we have created in this web tool. I will show you how. So we will create a class face controller, and we extend it from Flare controls. It's also from the Flare plugin. And if we do this, we get access to this initialize method, and we override it. And there inside, we have access to the Flutter actor artboard, which is a similar thing which we saw before in our Flare web tool. So it's like the root artboard, and underneath are all the nodes which we have created. And then we can say like artboard.getNode and get the different nodes we want to access from this Flare web tool. And we will save it here to an actor node solo, which is because we have a solo created for this, which is again like toggling between the visibility of this element. So we can show the hairs or make them disappear. And the next thing what we do is like we create this method show hair and go to or access the property active child index on this hair object. And then we set it to the index 1 if we want to show the hair, and to 0 if we want to make this hair to make it to disappear. And this is then how it looks like. So we have our application, we have a button here, show and hide hairs. And every time we press on this button, this show hair method will be executed. And so we can control it in our Flutter application. Another thing I want to show is we have created this animation. I've named it here head rotation. I think I forgot it in our project, but normally you give it a name. And then you go to your face controller and execute the method play. And there you put the name of the animation you want to execute. And yeah, so you simply can integrate it into your Flutter application. So every time we press on the wave head button, this wave head method will be executed. All right. And yeah, I think that's it. I've also created this here. Like if you tap here on the screen, it will follow your gestures. And I showed you how to do it with Flare a little bit. So you have here something in the middle, and if you move it then around in your Flutter application with a little bit more source code, it will move around. However, I don't want to mention everything because there's some source code going on, and if you want to check it out, you can go to my GitHub page, to github.com/JohannesMilke and Flare animation, and then you can check out this project, and then you can also see how this is everything done. It's pretty easy, but I don't want to go more into detail. And yeah, if you like, you can also follow me on Twitter, twitter.com/JohannesMilke, or subscribe to my YouTube channel, which I have. And yeah, the last thing is we are hiring Flutter developers. This is what my boss said, like, okay, ask if you are going here, because he got to know it. And yeah, if you're interested and you are accidentally moving to Berlin or something, contact us and it would be great. All right. Any questions?
Is it possible to import stuff in Illustrator, or do I have to draw everything directly on that? You know that?
Good question.
So the question was if you have to draw everything right now in Flare itself, and I think it's not the case because you can basically just export as an SVG and then import the SVG into Flare, right?
Yeah.
And then you have, yeah, exactly. And then you have basically the path you draw into drawn into Illustrator. It's also there. So yeah, I just wanted to come here and rephrase the question. Otherwise, the people won't hear it on the live stream. Okay. Anything else? Yeah, Christopher.
Did you know how they are rendering all the details, all the lines? Is this Flutter engine draw these elements, or just an own 2D graphics engine?
They integrated everything into Flutter, so they have this plugin where they created everything inside. I think they use solely Flutter for it.
So
Yeah,
I can see the widget tree.
Actually, I don't know how they do it like internally, but probably they will have something like a render element, which then does the rendering of the Flare binary. I guess so. I haven't looked into the source code yet, but I think it will be that way. But I think the dependency itself is just like pure Dart code. Okay, cool.
More questions? Okay.
Does it add much size to the generated APK or generated iOS app at the end?
You mean like this binary file or this plugin?
Binary and the plugin.
Yeah, we can.
How much is the binary file?
Yeah, let's see. I never checked it. 4 KB. I think it's not that big, right? I don't know how big the plugin. I don't think so. It's like source code.
But at the end, you put like different sizes for different platforms and so on. Every like kilobyte, just like make difference.
Okay. Yeah.
It's pretty cool for such animation.
Yeah, and I think they will do more, or they will invest more time to make this tool even more better because it's in the beginning state, and yeah, maybe there are more designers going in this direction.
I believe so. Anything else? Any other questions? No. So yeah, thank you so much, Johannes, again, for presenting today. Again, I want to say, well, I just switched this off here. I want to say thank you so much for being here today. Again, we had like a lot of people show up, and also to the people on the live stream. Thank you for those who are still online. Yeah, I hope if we can change anything, like also here, your feedback is very much appreciated. So if you have any comments on what we could improve, I know maybe the live stream is not 100% perfect yet because we only have like one camera set up. Maybe if the talks were too long, too short, just like give us your comments, let us know. You can ping us on Twitter at flutter.school or Georg and me on our personal Twitter accounts. Yeah, and for now, I would say you can still do some networking and discussion, but the live stream at this point, I think we will end here. So again, thank you very much, and yeah, thanks for coming.